what we have here is my alarm circuit. Going from the start, we have a PIR sensor on the input and a vibration sensor on the input. This is the reset switch for the microcontroller. I've designed the PCB to have two circuits effectively, one for the PIR signal conditioning, amplification and a comparator, and a similar circuit for the vibration sensor, and then a microcontroller at the end. I'll explain why it's not there in a second, with an LED for the output. First of all, the PIR sensing circuit. What we have is it detects movement, it is amplified through a small amount in the first bit, as well as filtered through a bandpass filter. This bandpass filter stops any unwanted frequencies. The filter only goes up to about 120 Hz, and the gain of the first amplifier is only about 5 decibels. And it then feeds into a second amplifier with a much higher gain of about 54 decibels. In total, the PIR signal is amplified by a gain of about 500, which is then put into a comparator, which will give it a 5-volt output signal, which is capable for the microcontroller to process. With the vibration sensing circuit, first of all we have a low pass filter. This low pass filter is designed to allow the frequency of the vibration sensor, which is about 70 Hz, to be filtered, the unwanted frequencies to be filtered out, and for the frequency of the vibration sensor to be fed through. That goes through an op-amp, which is acting as an active filter with unity gain, so of 1. It is then fed into another op-amp, this time being used for amplification, with a gain of about 65 decibels. This gives it a gain of about 500 if you're talking sort of like multiplying terms, which then again, like the PIR circuit, goes into another op-amp circuit which is acting as a comparator. Both comparators use a diode to block any negative voltages, because both the PIR and the vibration sensor will give a positive and a negative swing. This then, hold on, I'll just knock this off. This then, after the diode will obviously only let above 0.7 volts through it once it's biased. It is then going to be a much bigger signal because obviously it's been amplified. It could be, well in this case it's closer to 20 volts. It can only be 5 volt signal for the microcontroller, and that is done with a 5.1 volt Zener. So anything above 5.1 volts biases the Zener diode and is shorted to ground. That is enough signal to trigger the microcontroller. The microcontroller is actually missing because it's not working. As you're already aware, Dean, I had problems with this circuit. I found what the fault was. It was one of the op amps with short circuit within it, but it had also taken out the microcontroller. I do not have another microcontroller and cannot get hold of one in this short frame time. So what I will demonstrate is the signal from both the vibration sensor and the PIR sensor getting to the point at which it reaches the microcontroller. In other words, I'm going to show you the 5 volt signal that will trigger it. Okay, now I've got a positive and a negative supply, and I'm providing the 5 volt supply from an external source. It's actually a USB charger because I don't have a 5 volt supply, and then I'm going to show the output on an oscilloscope. So if I apply power, which is all's well, and what I shall do first of all is clip onto, clip's working correctly, clip onto the output of the amplifier, if I can get on again. and what you shall see on the scope is a sine wave when I bang the table. Or maybe not yet. Of various amplitudes, and then if we clip on to the output, the output of the comparator op amp, you should see a more squarish type wave, but with positive and negative elements to it. As you can see, I can't freeze it, but you've got an amplitude of about 40 volts going plus and negative. And then if you go on the comparator output, what we have is, and then I'll take my volts per division up, a much smaller signal of 5 volts. There's still a little bit swinging low. That could indicate that the diode's leaking slightly. Oh, that was a bit too hard a bang. And then if I do the same on the bottom circuit, be able to see it for the PIR sensor. And then if I then go on to the output again, which is over here, we should hopefully see a square wave when I move my hand over. It's quite sensitive, the PIR sensor. And if I go on to pin 6 of the microcontroller, which is where they're both wired into, we should see it again. I'll do both the PIR sensor and the vibration sensor to show they're both going there. First of all, PIR, just waving over the top of it, and then if I bang the table, I'm getting it there. Like I said, I haven't got a microcontroller to test, but when we initially tested this circuit maybe 4 weeks ago, the LED came on, so the program inside of the microcontroller worked. I forgot to mention these two variable resistors are to adjust the threshold voltage on how the comparators work. The threshold voltage works like a voltage divider with a set resistor. So the input comes in and you set this threshold voltage so that you get the optimum output. It may be that the output wouldn't be high enough for the 5 volts. You can adjust that by using the variable resistors. I think I described the top circuit as PIR and the bottom as vibration when I first started. In fact, it's the other way around. That top part is the vibration sensor and the bottom part is the PIR sensor. These 5 leads here are for programming the microcontroller. I I didn't have any pins to slot onto, so I've been using externally, just plugging it straight into the pit kit. Those were the power leads there, and that's about as much as I can describe on this circuit. Like, as you're aware, I've got a power supply circuit as well, but I've been unable to get that repaired. And I hope you're happy enough with this. This is Philip Vines and Alistar Chadwick's presentation. Thank you.